them. We got this far yesterday. To find the other two, we need this piece. And this would be the equivalent work of if you kept simplifying the double angle, the tangent double angle formulas, instead of just leaving it. But we're not going to do that, but I'll double angle sum and difference. I think I meant sum and difference, but we're not doing that. But this would be the equivalent of that. I'm going to separate these first. And get the square root out of the denominator by multiplying by its conjugate, which is the opposite sign. When you do this, really you have these two things being multiplied all underneath the square root. And I could rewrite these by saying this is really the same thing twice. And I could distribute this because this is difference of squares, and I get 1 minus cosine squared. From here, things start to change. My square and my square root cancel. Here, I know that 1 minus cosine squared is sine squared. And then again, my square root and my square cancel. That's your second tangent half-angle formula. Just like for your double angle cosine, because there was 3 different ones, for this one you can use whichever one you want. Notice that this one doesn't have the square roots, it doesn't have the plus or minus in the front, so those things don't follow. You wouldn't have to worry about whether the equation is positive or negative for this one. To find the very last one, you would do very much the same thing, except do the opposite. So instead of multiplying by 1 minus 1 minus, I would do 1 plus 1 plus. This work is going to work out to be very much the same. I'm not going to do it again. But you end up with the square root of this squared all over 1 minus cosine. Sorry, I did that backwards. So this should be opposite. And then the same things that canceled before will cancel again. That becomes sine squared, and then the square root and the square go away. And that just becomes 1 plus cosine, which is your third. So whichever one you want, pick and choose. Remember, memorizing it would probably be easier than going from the double to this. Now let's actually use this. So we're going to do 29. Writing this. So there are two different types of half-angle problems you might see. The ones where they give you some angle, that will be one type. When you look at it, it looks very similar to the sum and difference ones that give you the angle. So on the test, that will be specific as to which one it is. And there are a couple things we need to do with this. First, notice that this is not something on your unit circle. It shouldn't be. It should be some half angle. Where would this angle lie? In the second quadrant. Because that's our half angle, that's going to determine whether our equation is positive or negative. So the half angle also always determines whether the equation is positive or negative. You got this.
An equation equals negative.
I'll just rewrite it because that was terrible. I wrote it very sloppily. Okay. And then to actually find the values we're going to use, we need to find some angle on the unit circle. So since this is a half of some angle on the unit circle, we're going to multiply by 2. What would that be? Not 230. It is 2 something. 225. Now remember your tangent half angle formulas, depending on which one you're using. You either need cosine or you need sine and cosine. For this one, we're going to do it. We want 2 different ways so you see what happens. So at 225, that's in your third, is cosine and sine, are they positive or negative? Negative. And that's going to determine the value. So one determines whether your equation is positive or negative, and one determines if your value is positive or negative. What is the cosine of 225? Negative root 2 over 2. And then the sine of 225? So writing those down is not necessary, but you were already thinking of a lot, so writing it down may be easier. Once you have all of that information, you can actually use your formula. So we're going to start off by using this one, so you see what that looks like, and then we'll do another one. We won't do all 3 though. Which one? We're going to start off by doing this one. That's up to you, really. One has more simplification than the other. Jerica's and Zoe. You'll get different answers. For these, you're going to get different answers, and that's okay.
So wait, I'm so sorry. Just like clarify, like it doesn't matter any one of those. Any one of those. Okay. But we have to do that step first. Right?
Yes, you have to do this part first.
Okay.
Now,
you have practice on this? Like,
yeah. Okay. For this piece, This only applies to this first equation. If you're not using this one, this doesn't matter. So you don't have to do that if you're not using that first one for tangent only. You may have space in your box, I don't. So from the work we did above, we know that our tangent equation is negative. That means we need to keep the negative throughout all of the simplification. We know that our cosine value at 225 is negative root 2. So I'm going to put that in. Once you get to this step, everything else is just simplifying. Condensing, simplifying. You need to combine these fractions by getting common denominators. I'm going to do this first. Because I have two negatives and I have a plus and a minus, I'm going to combine those first. And get common denominators, combine your fractions. Then you have fractions within fractions, so multiply by the reciprocal of the denominator. Your entire denominator is gone. These 2's are gone, and you're left with 2 plus root 2 all over 2 minus root 2.
I have a question.
Ask it.
Because when I get home, I'm gonna go back and watch this thing all over again. Can you cross out the multiplication altogether? Ah, there we go. Thank you.
Should we leave the square root? Should we leave the square root?
Yes. Because if you wanted to get rid of the square roots underneath the square roots, you would have to go through that process we were doing when we were proving this. That process right there, I don't want you to do that.
Yeah, I want to do that. So great.
So that would be your answer if you use the first one. That's your personal opinion.
So wait, what's happening at the top? It's like, is it always subtracting? Or adding?
Sorry, where?
Wait, she's just like, so check out the power.
Now, I'm not going to do the second and the third because they'll be very similar, but I'll do the second one. So we don't need to know whether the equation is positive or negative. This is the second one. We do need to know cosine and sine for this one, though.
Is there ever going to be a case where when you multiply it by 2, it doesn't equal something on the circle?
For the So with the second and the third, you simplify a little bit more. Still need to combine these fractions. I'm going to rewrite it first, so. Combine them, get common denominators in your numerator. You still have fractions within fractions. You would still multiply by the reciprocal.
Couldn't you take out the 2's?
We're going to do that last.
Oh, sorry.
So when we do this, our denominator is gone, our 2's are gone. I'm going to write this like this for now because I still need to rationalize and multiply the negative in.
Can you show what crossed out again?
I moved the negative. I haven't done anything with it yet. So in that step, I used my negative, multiplied everything by the negative. But you still have to rationalize. So before I simplify anything, I'm just going to write it out as I'm distributing. -2, √2, minus, those would become 2 all over 2. And then I can divide everything by 2.
Wait, what was the other answer? No. So would it have been the same if we kept going on the
If you kept going, simplifying, yes.
Okay. So it doesn't matter though, like we can use either one.
Right. Because one has more simplifying than the other. So that is your personal preference. I will say that the other one got an answer very similar to this, but you ended up with a 2 instead of a 1. Still same thing. Okay, I know that was a lot, but do we have questions? Yes.
Did you found the other trig functions that multiplied the angle by 2?
Yes. We multiplied the angle by 2 and looked at, on the unit circle, what is sine, what is cosine there. We're going to do a couple more. Let's do this cosine one. Cosine of 75. Where would 75 be on your unit circle?
The first quadrant.
In the first quadrant. So that's going to tell us that our cosine equation is positive. And then again, multiply this by 2 to find something on the unit circle. Where would that be? 150, which is now in your second. For cosine equation, we only need cosine. cosine's value in the second quadrant at 150 is negative root 3 over 2. The value is negative. And then we can use that information and put it into the formula. Thanks. Since the equation is positive, we don't need to put a plus out front. Just leave it. But we do need to put this in, the value. And from there, start simplifying. As you start to do this more, you may not need to simplify every single step. You could have skipped this step and just wrote 1 minus. You could go directly into combining the fractions. You could start skipping steps, but I'm just going to continue writing them. You still have fractions within fractions, so multiply by the reciprocal. So we end up with the square root of 2 minus root 3 all over 4. Yes, Jericho.
Can you write your final answer? Do you have to write cosine theta over 2?
Yes. I just don't have space to continually write that.
Wait, what?
We haven't gotten there, but I'll show you what she's talking about. The very last thing you need to do is to separate this fraction by taking the square root of your numerator and the square root of your denominator, because you can take the square root of 4.
If you couldn't take the square root of 4, would you have to separate?
You would have to simplify it. You wouldn't have to rationalize it, but you would have to simplify it.
Wait, how come?
Yes.
Actually, no, I don't know.
How come what, Landon?
I don't know. I think I got it, actually. Wait, so
So your final answer is the square root of 2 minus the square root of 3 all over 2. That 2 is no longer in the square root, because we took the square root of 4. What questions do we have right now? We're going to do one more of these types together. I've run out of space to do this. Okay. Now you have some radian, 5 pi over 12. For this, you could do one of two things. Either convert this to a degree, figure out where that would be, and then multiply it by 2. Or work backwards, multiply it by 2 first, and then divide it by 2. So I'm going to do that first. Multiply 5 pi over 12 by 2. And simplify. 5 pi over 6 is what as a degree?
150.
150. and the second. So because we are in the multiplying by 2 stage, this is talking about the value, not the equation, because we skipped a step. But we're going to go back.
Bless you.
Bless you.
Bless you.
Bless you. Oh, jeez. Remember, even though we're doing the sine half angle, sine's equation has cosine in it. So we still need to figure out what the cosine value is. Now to go back, if we know we're at 150, half of that would be 75 in the first.
Oh, so you divide it by 2?
Yeah.
Okay.
To figure out where that is. And you could just keep going backwards. So that means your sine equation is positive. And then we can go ahead and find what is the sine of theta over 2.
Ew. I do have tissue, guys.
Please use it in the head.
So our equation is positive. We don't need to keep writing that. I didn't actually write our cosine value, but it's negative root 3 over 2.
Wait, cosine of what?
150. Are you alright?
Yes.
And then start the simplifying process.
You sure? Because you sound like it. Oh, shoot.
Combine the minus and negative. Got common denominators, combine the fractions. Multiplied by the reciprocal of the denominator. Took the square root of both your numerator and your denominator. Notice that this answer and the previous answer look very much the same, except one's plus, one's minus. That's going to happen a lot. Especially because they're basically the same equation, except for one's plus, one's minus. So once you get the gist and the hang of what to do in the beginning and then the simplifying process, it's not so bad, it's just a lot.
How many days are we going to get on this test?
This section is not a long section.
So, like, is it just like a couple of problems instead of
It'll be like one of each type.
Yeah. Okay.
You guys just have a bunch right now to practice.
Oh. Oh, guys.
Okay. I'm going to let you guys practice here in a second. I do want to talk about the last type of half angle. So it's very similar to what we were just doing, but it's also different. So we're going to do 33. With this, light bulb should go off telling you this is half angle because of this theta over 2. In this, you also need to recognize what you're actually trying to find because there's so much up here, it's confusing. But we're actually going to be finding the sine's half angle, even though it says tangent. This should look kind of similar to how the double angles were set up. because it is. The process is very similar, but again, also different. Pi to 3 pi over 2, where is that? In the third quadrant. This is telling us that this value is positive. Tangent's value is positive, obviously it's a given. But I don't need tangent, sorry. Because I'm looking for sine, I really need cosine's value. What will cosine's value be in the third? Negative. To find whether or not the equation will be positive or negative, we need to find our half angle. To do that, we're going to take this domain and divide it by 2. Divide everything by 2. Because this is where our half angle would lie. So it's a little different than what we were doing before when we were given the half angle and had to find the actual. Where would this lie? In a second. So that means our sine equation is going to be what? Positive.
Is that the 3 pi over 4?
Yes. So what we knew about how to find the the equation and the value have now switched for this type of problem. The last thing we need to do before we put everything into the equation is find either your cosine, for whatever this is, find the actual theta, exact value, and we need to find cosines. When we were doing our double angle, we talked about our x, r, y definitions, how this is y, this is x, we need to find r. So we're going back to that. Using our Pythagorean theorem to find r. Because we need to find cosine, and that's x over r. So r is going to be 10, the square root of 10. Yes.
Wait, we're finding cosine?
We're finding cosine's value. Yes. We're doing sine's equation, but we need cosine's value to do it.
Wait, I thought we were doing tangents.
No. They gave you tangent as a trick.
Like, how come? So wait, I'm confused. Wait, how did you know what cosine was?
It says to find sine.
In sine's equation, it says 1 minus cosine. So we need cosine's value. So really, you need to know your formulas and what you're looking for.
So like, even if it says tangent, you just have to like look at the equation and be like, you can't find tangent, so you have to
So for
find cosine.
Tangent's equation, it depends on which tangent one you're using. If you're using the first one, you need to find cosine. If you're using the second or third, sine and cosine. It depends. You never need to find tangent though.
So for these, you never ever find tangent.
Wait, we just found 2.
For a different type of half angle problem, not for this type. What is cosine? That's r.
R over Y over.
Oh.
X over Y.
So 3 over root 10. But it's in the third, it's negative, we have to magically make it negative and rationalize.
So that is cosine.
That is cosine's value. Now we can put that in sine's equation and find sine. It's a lot, I know.
Negative 3 root 10 over 10. Wait, so the equation would be plus, right?
Yes. I just rewrote it.
Wait, so if your answer is finding sine and cosine?
Your answer is doing this. We haven't even found our answer yet.
Okay,
We need
so
to put this in
okay, so
here.
you're just doing the okay, yeah. Because it says the
Why is that mean?
Okay, but why don't I look like that?
Who is that? Why does that actually look kind of like you? It looks like you as like a child. That's so terrifying. Oh, that's so bad. So now what?
We need to simplify. It's not going to look nice.
Of course it's not gonna look nice.
If you had something like 10 plus 2 root 10 over 10, then you could simplify. We can't, because we have that 3. We can still multiply by the reciprocal. So we end up with 10 plus 3 root 10 all over 20. No. We do need to simplify, but we don't need to rationalize. So separate your numerator and your denominator. And simplify the square root of 20. What would that be? Square root of 5. So when you get these answers, they're not going to look nice. You're going to want to fix them, but don't. For your sanity and mine, don't.
Is that our answer?
Yes. So tomorrow, because we don't have much time in class, you can keep working on the examples, but tomorrow is just going to be a practice day. So that you can practice these examples.
And it's the 2, right?
Yeah. So the 2 Khan Academy Student Friday is on sum and difference, and one is sum and difference and double angle combined.